Hey folks, it's Tuesday the 30th. Let's look at today's questions. Again, starting with Foundation Plus. So we're starting off with some simple bracket expansion. You need to obviously multiply each term inside the bracket by the term outside. That means numbers get multiplied together. So our numbers are going to be 20 and 8. And then if we go y squared times y squared, we're going to add those powers, y to the power of 4, take away, and then it'll be a y squared or y squared a. That looks a little bit rubbish. Let's try that again. A y squared. There we go. Okay, next one. Solve quadratic. Again, what's the first thing? You need to make the one side is 0, which it is. So then you go to either quadratic formula or you go to factorizing. This feels like a factorizing one to me. We need two numbers that add to 3 and times to minus 4, and the numbers that do that are going to be 4 and minus 1. So we can go x plus 4, x minus 1, and then that will tell me that x is minus 4 or x is 1, and that's the solution. If you were to use the quadratic formula, we would have minus 3 plus or minus square root of 3 squared minus 4 times 1 times minus 4 all over 2, which would simplify to 9, this is. That's 16, so 9 plus 16, so 3 plus or minus square root of 25 over 2. So plus or minus 5 over 2, and then when you do a plus, it would give you 2 over 2, so 1. And if you were to do a minus, it would give you minus 4. Either way, gives you the same answers, obviously. Okay, estimate of the mean. So this is the classic like question 6 or 7, 4 marks. If you want to estimate a mean, you need to add on 2 columns. We need to add on one for midpoint, and we need to add on one for fx, or frequency times midpoint. It's going to look a little bit unholy, but we'll see what we can do. Again, if you want to find the midpoint, it's between two values, so between 1.5 and 1.55. You could add them together and halve it, but we should have midpoint-wise 1.525, 1.575, and so on. Just be careful you don't get in too much of a habit. So this one, that's going to be 1.7, and this one's going to be 1.8, and then you need to multiply across. So let's do that. Okay. Now at this point you're on about 2 marks out of 4. To get the rest of the marks, we need to add up the frequencies, and we need to add up the fx's. And then add up the fx's. Gives us 98.2. And then to actually get the mean, we need to divide. Three significant figures is fine, so I'll go with 1.64. There we go, that's our mean estimate. Got a simultaneous equation here. There's a few ways you could look at this one. I think in my case, I would say, well, if y is x plus 2, then I can swap that in for the y that's over here. You could do like a straight substitution, and that would give you x plus 2 plus 1 is 2x, x plus 3 is 2x, and then I could take away x from each side and get 3 is x, and then as y is x plus 2, I could also get that y is 5, and that would be done. Another way of doing that question would be to rearrange it so they're both in the sort of familiar format. So I could rearrange the top one to be y minus 2x equals minus 1, and I could rearrange the bottom one to be y minus x equals 2, and then I could do a subtraction, and I can end up with something like minus x is minus 3, so x is 3, and again get to y equals 5. You know, you've got options about how you approach this sort of thing. It's just trying to get rid of one variable through whatever means necessary. Okay. Lastly, we've got ourselves a Venn diagram. So let's draw a diagram. It says that A is multiples of 4 and B is factors of 20. This symbol here means like the entire list that you're considering. And we use these little curly brackets to say here's a set of numbers. Okay, so we've got multiples of 4 and factors of 20. It would be good to think about what these are. So factors of 20 are 1 and 20, 2 and 10, 4 and 5. We're obviously going to need an outside box as well for things that aren't either of these things. I generally find it a good idea in these scenarios to just label things. So multiples of 4 are 4, 8 and 12. That's what's going to go in the A circle. And factors of 20, that's 1, 2, 4 is both, 5, 10, and 20 is not on my list. Okay, so I can now put this all together, draw a Venn diagram for this information. So we kind of want to put the numbers in the right place. So we'd have 1 here, 2 here, 3 on the outside, 4 in the middle because it's the only one they both got in common, then 5, 6, 7, 8, 9, 10, 11, and 12. There you go. Cool. Okay, so that was higher Foundation Plus. Let's go up to grade 6 and 7. Okay, so this one, in theory, I think it's something called geometrics, but realistically, we're probably not going to do it that way. Maybe you'd think about this as compound interest. Every time a ball bounces on a surface, it rises to 4/5 of the previous height, drop from 5 meters and bounce freely. Well, how long does it take before it rebounds less than 3? Okay, so this seems fairly straightforward. We'll start with 5 meters, and then it'll bounce, and we want to times that by 4/5. So if we do that, that gives you 4. Okay, so it's still not less than 3 meters, so let's times by 4/5 again. I'll give you 3.2. Okay, still not less than 3. Times by 4/5 again. And that's 2.56. And that's about as far as we need to go. So what is the smallest number of bounces until its rebound height is less than 3 meters? So it bounced once here and went back up to 4, then bounced again and went back up to 3.2, then bounced again and went back up to 2.56. So 3 bounces needed. Okay. Box plot. So we've again had one of these quite recently. Just as a reminder, your box plot needs to look something like this. You've got your lowest value and your highest value. You've got your median in the middle, lower quartile, upper quartile, and then we've also got interquartile range is the difference here, and the range is the difference between the biggest and the smallest. So using the information we've got here, we'd want to scale, obviously. The lightest player is 50, so we want to start at 50. The range is 40, so the heaviest is going to be 50 plus 40 is going to be 90. So we want to go from 50 to 90. 1, 2, 3, 4. Yeah, okay. So we can have this be 50, and then just go up in tens would make sense to me. So we'll have a line for the 50, that's the lightest one. A line for the 62. A line for the median at 72. A line for the 90, which is our heaviest, that's 50 plus 40. And then we need to decide our upper quartile. So remember that the difference between the lower quartile and the upper quartile is 20, and is also the interquartile range. So if we add 20 on that, we'll get the upper quartile as being 82. And just to repeat, we added on 40 to that to get the highest was 90. So our upper quartile is 82. Let's make a mark there. And then all we need to do is put it into a box plot formation. Cool. Okay, let's move on. So indices, if you've got a fraction, the top number is your power and the bottom number is your root. Power of 1 is not going to make too much of a difference here, so all we're doing is a square root of 9 over 25. Now if you have to square root a fraction or put a fraction to a power, you just need to square root the top and the bottom separately. So square root of 9 is 3, square root of 25 is 5, that's it. Okay. Factorising, but slightly more complicated factorising. Okay, this obviously can be done with a little bit of trial and error, but I think this is a good opportunity to talk about the MAM method. So the MAM method is that we want to do this sort of methodically, step by step, and what we want is two numbers that multiply to 7 times 1, and we want numbers that add to 8. So what are the numbers that would do that? That would multiply to 7 and add to 8? They are 7 and 1. And what do we do with that? Well, we use that to split up this 8x in the middle. So here's what we'll have. We'll have 7x squared plus 7x plus 1x. And now I'd normally write x, but it actually helps a lot if we write it as 1x plus 1. So all I've done is I've split up that middle term. What do you do then? You factorise each half. So we have a step which is to split, and then a step which is to factorise. So we basically like draw an imaginary line down the centre. I can put 7x into both of these terms and it would factorise to be x plus 1. I can put 1 into both these terms and it will be x plus 1 inside the bracket. And if those brackets are the same, you know you've done this right. And then our last step, let's say combine, would be to put this 7x plus 1 into a single bracket. And just to be clear, that's from here and here. And then to put the x plus 1 into another bracket. And that's it. Cool. So MAM is well worth knowing, by the way. That's like as hard as factorising is going to get, and it's not that bad as long as you know exactly what you're doing with it. Okay, lastly we've got to prove that. Now if we want to prove, we need to start with one side, so I'm going to start with the left hand side. And then I need to get to the right hand side. You know what? Actually, I'm not going to start with the left hand side because the left hand side looks simpler. It's generally easy to make a complicated thing simple and a simple thing complicated. So I'm actually going to start with the right hand side and I'm going to get to the left hand side. So the right hand side is x minus 2, x plus 1, minus 4. And I'm going to expand this. So that's going to give me x squared minus 2x, oh, that's from that one, plus 1x, and then minus 2, minus 4. And then I can simplify this. So I've got overall x squared, overall I've got minus x, and overall I've got minus 6. And then if I was looking to factorise this, I would want to have two numbers that add to minus 1, that times to minus 6. And so the numbers that do that will be minus 3 and 2. So it will be x minus 3, x plus 2, and that is what I wanted to show. So again, it's one of those identity things. You've got to show that one side is exactly the same as the other side. Now obviously if I wanted to do the other way around as well, I could have done. You just kind of read this from bottom to top, but that feels a bit more complicated to me. So I'd want to pick the complicated side and change it to the simple side. Okay, that's the end of higher. Onwards to higher plus. Okay, so we've got nth term of a quadratic sequence again. So let's see a reminder here. We want to find the second difference is the first thing we want to do. And we're eventually going to want to find the 0 term. And the second difference is 2. So our value of a, or the value of n squared, divided by 2, is going to be 1. So the nth term is going to start 1n squared. If we work backwards, we can get the 0 term up here as being 12. Because we had to subtract 1 to go to 11. Just be careful on like how your signs work out there. So we know this is going to be plus 12 at the end. And then the last bit of this is the middle bit, is to get the first term using the numbers we've already got. So 11 is 1 plus 12 plus something. So 11 is 13 plus something. So that something is minus 2. So that tells us this is minus 2n. And there's our nth term. Now we could write that as just n squared if you wanted, but you wouldn't get like extra marks for doing that, it just looks better. Okay. Ooh, this one is interesting. So this is a quadratic inequality, and you tend not to see too many of these. So let's go through the steps. First step you want to do with this is to factorize. And that is adds up to minus 4 times is 221. That's going to be that. Minus 7 and 3. Done loads of factorizing today anyway. And then your next step for this, I would say, is to sketch it. And this is good practice for sketching quadratic graphs in general. What shape has this got? Well, it's got that sort of shape because it's a positive quadratic. Where does it go through the x-axis? Well, it goes through at x equals 7 and x equals minus 3. So putting those two facts together, you end up with a graph that goes like that. Okay, what do we want to know? We want to know when this is greater than 0. And that's going to be here and here. Those are the bits where the graphs are above the axis. How would you write those two things down? Well, we'd say that x either has to be less than minus 3 or x has to be greater than 7, because we're talking about values which are less than minus 3 and greater than 7 on that graph. So that's the process. Okay, another proof. Interesting. We are trying to prove that this is positive for all values of x, so I think like your obvious first step is expand it, simplify it, see what you get. So let's do that. We would end up with 9n squared plus 12n, and then just remember, if you're expanding n minus 6 squared, you're talking about n minus 6 times n minus 6, which is n squared minus 6n plus 36. That's n squared minus 12n plus 36. So let's combine that. So that's plus n squared minus 12n plus 36. And simplify. So we've done step 1, which is always expand, and then we will simplify it, which will give us 10n squared. The 12n's will cancel out, plus 36, and then so we want to show this is always positive, and what this equals is a square plus 36, and that is positive because squares are always positive. And that would do. You could also complete the square at that stage, I suppose, as well, but that seems like the obvious way to prove it to me. Okay, and then a bit of straight line stuff to finish off. So again, we've got words like perpendicular, we've got words like equation of line, we've got a coordinate that we're maybe going to use. We've got this line that goes through these 2 points. So what do we need to do first? And then we want to find like the equation of this line, which is perpendicular to D and passes through F. I guess I could label my points if I wanted. I could say this is 0, 10, this is 5, 1, and this is 0, minus 6. But if I want the equation of this perpendicular line, then I need to find the gradient of the line in the first place. So I need to find the gradient of DE. So it's change in y over change in x, so it's going to be 1 minus 10 over 5 take 0, which would be minus 9 over 5, or I guess minus 1.8, but I'm going to do perpendicular stuff with it, so it's probably best to leave it as a fraction. Now looking at that, that's negative, that's fine, because the line appears to be going downhill, so that's okay. Okay, so step 2 would be the gradient of EF, because that's what we're trying to do in this first bit, find the equation of that line. And remember, it's a negative reciprocal, so you flip the fraction and you change it from negative to positive, and done. Next step would be that we want the equation of EF, and this would be where we use y minus y1. So here's our x1, y1, and our m is 5/9, so we would have y minus minus 6, so plus 6, equals m, so 5/9, x minus 0, that's nice. So we could expand this. We could say that y plus 6 is 5/9 of just x, and then we could simplify it. So 5/9 of x minus 6. So there's our first answer. Y is 5/9 of x minus 6. What else do we have to do? Find the shortest distance between the line passing through DE and the point F. Okay. So there is basically a fact that they wanted you to use here, which is the shortest distance between a point and a line is always at right angles to it. So if we draw the scenario that we've got this line DE, we've got this line EF that's at right angles to it, and then what it's essentially wanting you to do is to find this distance here, to find the distance between the point it goes through and there. Now, how do you actually do that? Well, Pythagoras is probably involved, for starters. Let's actually try and draw this a little bit less terribly. But I want to find, like, this length here. Let's call it x. I know some things here. I don't know a lot of things. I think what we have to do is we have to find this point here. We have to find the point where the things cross, because then we can do something with Pythagoras, basically. For starters, I can say that this distance is 16 for what it's worth, because it's the difference between minus 6 and 10. Okay, so we want to find this. How do you find a point where two lines cross each other? Well, you solve some kind of simultaneous equation using their equations. Do we know the equations of both lines? Not yet. We know the equation of the line E to F. We don't know the equation of the line D to E. So before we can find that point, we're going to need to find the equation of D to E. I'm going to need some space for this, so let's go up here. We're going to find the equation of D to E. How do you find the equation of D to E? Well, we know its gradient is minus 9 over 5, because we had that before. And here's where we can be extra smart. We also know it goes through the y-axis at 10, because, well, we were told that. So, there we go. That's the equation of DE. Now, if we want to solve, there should be an x in there. If we want to find where they cross over, we then need to set them equal to each other. So we need to find the crossing point. So I'm going to do, as y equals 5/9 x minus 6, and as y also equals minus 9/5 x plus 10, we'd set those things equal to each other because they're both equal to y, and then we'd want to get all of the x's on one side, all the numbers on the other, so obviously add 6 on the other side. And then I am going to go ahead and use a calculator to do 5/9 add 9/5, because it doesn't sound like a nice one. And then divide by it, and that'll give me that x is equal to, oh god, absolutely horrendous, 360 over 53. or I don't know, what would that be as a decimal, 6.79, maybe I want to use that. Okay, so we've got that. Now what do we need to do? Now we need to find a distance on a line. So I want to find the distance from here to here, maybe? Or actually, because I'm trying to find x, I could just find x straight away, couldn't I? Yeah, so let's do that. So if I want to find the distance in x, I'm talking about the distance between the coordinates 6.790 and 0, minus 6. So then I can find x. And to do that, it is going to be the difference in x squared, so 6.79 squared, plus the difference in y squared, so plus minus 6 squared. That'll do it. Trying to keep this as exact as I can in my calculator, but it's a little bit fiddly. So that would be the square root of 82.14, and that would give me that 9.06 is the distance between those two. Yikes. A lot going on in that question. Hope that was some help, and I'll see you tomorrow. Cheers.